All right, everybody, today we're going to talk about divisibility rules. So the word divisibility is a gigantic word. So the question is always, what does the word divisibility mean? So it means that a number can be divided evenly into it without a remainder, okay? So instead of doing long division for every number, there are some tricks or some number patterns that we can use to help us figure out if a number is divisible by something. So for the first one, for our divisibility by 2, we just need to look at this last digit. So in this case, there's not a last digit, it's just the number 2. And so we're going to test it to see if it's even. Now, an even number ends in 0, 2, 4, 6, or 8. So we're going to look at the last digit for each one of these. So this is a 2, so that is divisible by 2. This is a 4, that's going to be divisible by 2. This is an 8, so that is divisible by 2, and this one is a 0, so that is divisible by 2. So you guys have been skip counting by 2s for a long time, so this is one that you've probably been familiar with for a little while. You may not have used the word divisibility, but knowing that something's even, meaning that you can divide it by in. All right, so the next one's a little tricky. So there are a couple of math words in here we need to focus on. So the word sum means to add. So the sum of the digits is divisible by 3. So we're going to look at these digits and we're going to add them up and see if they're divisible by 3. So this first one, which is 9, doesn't need to be divided by anything, but 3 does go into 9 because 3 times 3 is 9. For this one over here, for 66, I'm going to add it. I'm going to do a little side math here. So 6 plus 6 equals 12, and 3 can go into 12, which means that 66 is divisible by 3. If we look at this next one, 4 plus 5 is 9, plus 3 is also 12, and we know 3 can go into 12 because 3 times 4 is 12. So that's divisible by 3. The next one, 3 plus 4 is 7, plus 5 is 12, plus 6 is 18. So that one is also divisible by 3 because 3 times 6 is 18. Okay, so that is our divisibility rule by 3. And please feel free to watch this video a couple times because I know that this is a lot of information. All right, so in this one, for divisibility by 4, you have to look at the last 2 digits. So we are going to look at these last 2 digits. We are not going to add them up. We are just going to look at them as a number. So for this number, this is 132. I know it's a little hard for me to see because I boxed it in a little too much. So 132. So can 4 go into 32? Yes, 4 times 8 is 32. So 132 is divisible by 4. The next one, 3,440. 4 goes into 40 10 times, so that is divisible by 4. The next one is 8,808. So 4 goes into 8 evenly, so that is divisible by 4 as well. Okay, so divisibility by 5. Now you've counted by 5s and 10s for a long time. When you look at a hundreds chart, you're going to notice that anything divisible by 5 ends in 5 or 0. So if you're skip counting by 5s, all those numbers are going to end in 5 or 0. So all we have to do now is look at the last digit. So this first one, it's just 5, but so 5 does go into 5. 25 ends in a 5, so it's divisible by 5. 360 is divisible by 5 because it ends in 0, and 5,670 is divisible by 5 because it ends in a 0 as well. All right, 6 is a little tricky. You have to think of 2 different rules, divisibility by 3 and divisible by 2. So the first thing I always check for is it even? Because if it's not even, I don't even have to check for this divisibility by 3. And the even one is probably your most, it's probably a little bit more straightforward because you're just looking at the last digit. So this is even, and 2 times 3 is 6, so this is divisible by 6. For this one, it is even, right? Because we have an 8, and then you do 1 plus 8, which is 9, and 3 does go into 9, so that is divisible by 6. For this one, it ends in a 0, so it is even. Then we take 3 plus 6 plus 0, which is 9, and 3 does go into 9, so that is divisible by 6 as well. For this one, our last digit is a 4, so it is even. Then we can check for 3, so 4 plus 5 is 9, plus 5 plus 4 is another 9, so 9 plus 9 is 18. So 3 does go into 18, so it is divisible by 6. So that one's a little tricky because you have to test for 2 different divisibility rules. The next one is 9. This one's really similar to 3 because we are going to talk about the sum of the digits, but this time it has to be divisible by 9. So now 9 does go into 9, so that one's divisible by 9. If we look at the next one, we're going to add this up. So 9 plus 9 is 18. Can 9 go into 18? Yes, it can. 2 times 9 is 18. 9 plus 8 plus 1 is also 18. So 9 does go into 18. 2 times 9 is 18. The next one, we have 9 plus 1 plus 9 plus 8, which is 27. And yes, 9 does go into 27 because 9 times 3 is 27. Our last rule we're going to talk about is divisibility by 10. And this, again, when you were skip counting by tens forever ago, you're looking at this last digit. Anytime you're looking at a number that you're skip counting by tens or you're dividing by 10, it has to end in a 0, right? 10, 20, 30, 40, they all end in zeros. So each of these are divisible by 10 because they are ending in 0. Okay, so those are our divisibility. I have, if we are doing one of these charts, what I recommend is, so what we're looking for here is testing the divisibility for this number, 5,224. So what I usually do is I think about, and I put this divisibility rules next to it so that I could kind of see what I was doing. This does end in 0 and 4, so it's even, so it is divisible by 2. For this, when I do 3 and 9, I always make sure that I'm jotting down what the sum of these are. So 5 plus 1 is 6, plus 2 is 8, plus 4 is 12. So I'm going to write a little 12 over here off to the side. 12, right? And then I'm going to keep going. So can 3 go into 12? Yes. So it's divisible by 3. And then I'm going to think, okay, for 4, I'm going to look at these last 2 digits. So 24, can 4 go into 24? Yes. 4 times 6 is 24. For 5, does this end in 5 or 0? No, it ends in a 4. So I'm going to put an X there. For 6, is it even and is it divisible by 3? Yes. So it is divisible by 6. And then for 9, this number that we added for the 3 is really handy. So can 9 go into 12? No. So you can see in a couple of things, just in terms of noticing this, a number can be divisible by more than one thing. There are also numbers that are divisible by nothing because either they're prime or they're divisible by numbers that we may not have talked about divisibility rules for. So there's any combination of checks or X's for any of these, okay? Let's do one more just as a quick example. So let's come way down here to 1,420. So it is even. And if we look at if we add this up, 4 plus 2 is 6 plus 1 is 7. So it is not divisible by 3 because 3 can't go into 7. The last 2 digits here are 20. 4 does go into 20. It does end in a 0 for a 5, so it's divisible by 5. For 6, there's a check here and an X here, which means it's not going to be divisible by 6 because you need a check in both. And then for 9, can 9 go into 7? This one over here, when we added it up, it cannot. So that's what this check and X box kind of ends up looking like. So this is just a chart to test divisibility by a couple of different rules that we've talked about. All right, I know I've given you a lot of information. It might be helpful to watch the video again or to watch the rule that you're focusing on as you do some practice. But these are I have given you guys a paper that looks like this, and it's a summary of all the rules that we just talked about. So this is a good reference for you. It also gives my examples for each one too. So it talks about the even. It gives you an example of how to find the sum. It highlights the last digit and things like that. So this is a good reference for you as well. Divisibility rules that we've been talking about. Thanks for listening, guys. Bye.